Hello, I am Kobayashi from Sony. In this tutorial, I will describe the process to use neural network models such as image recognizers in other applications by using from Python. These neural network models are created in Neural Network Console, our integrated deep learning development environment. While you can use Neural Network Console to quickly create image recognizers, in this video, I will teach you how to use these recognizers in other applications. Links are provided in the description to other videos that cover deep learning in more detail, as well as tutorials on using Neural Network Console. Please see these videos if interested in that content. As you can see here, many methods are available to implement models created in Neural Network Console in applications. Neural Network Console uses an open-source deep learning framework called the Neural Network Libraries for training and inference. So you can use the open-source neural network libraries to easily implement trained models in applications. A total of 4 methods are available to use trained models through use of the neural network libraries. This video will cover the first method of using the Python command line interface and the second method of using the Python API for neural network libraries. The core of neural network libraries was developed in C++, which means you can also just use a C++ environment instead of using Python. Runtime libraries in C, not C++, are also available to develop compact implementations. Neural Network Console also supports the ONNX exchange format for support of deep learning libraries from other companies. Exporting models trained in Neural Network Console in the ONNX format enables you to use models trained using other libraries. For more information on methods 3 through 5 as shown in the video, refer to the following documentation. We also intend to release videos in the future to cover these methods. Now, I would like to go over the process to run inference using the neural network libraries via the command line interface, which is called CLI. First, you need to install the neural network libraries in the environment in which you will run inference. The easiest way to install the neural network libraries is to run the pip install nabla command in the environment in which Python is installed. The neural network libraries is compatible with Linux, Mac, and Windows so that inference can be run on many different environments. Refer to this document for more information. Once you have finished the neural network library setup, use this command line to run inference. In this tutorial, let's run inference for an image classifier that will determine if an input is a 4 or a 9. The main command used is nabla CLI and the subcommand is forward. The forward subcommand means that inference will be run. The first argument C specifies the NNP model file obtained as the result of training. NNP files describe the different functions configuring the neural network and trained parameters such as weight values. In other words, this is the file that actually describes the trained model. This NNP file can be downloaded from the right side of the screen by selecting the training results on the Evaluation tab in the cloud version of the software. For the Windows version of the software, NNP files are saved in the applicable training results folder. The second argument, D, specifies the dataset CSV file containing the data to be used in the inference process. The format of the dataset CSV file used here is the same as the format used during the training process. For more information on formats, see the previous tutorial video that describes the process to create image classification datasets. While you need to prepare a column describing the correct labels expected as the output of the neural network in both the training and validation datasets used for an image classifier, for example, you only need the input image column in the dataset used to run inference. The column with the correct labels is not necessary. The last argument, O, specifies the output folder for inference results. Running this command line with these arguments causes the classification process to be performed on the specified data using the specified trained model, with the results being output to the output folder. After running this command, a file named output result.csv is created in the output folder. If you open this file, you will see that a column with the results of performing the classification process on the dataset CSV specified with the D option has been added. As you can see, you can use the command line interface together with the neural network libraries to run inference without having to do any additional programming. With this method, the trained model will be loaded from a file every time the command is executed. Also, because information is loaded and output via files, this is not the fastest method available, but it is an easy way to run inference. Depending on the deep learning application, this command can simply be called by another application, which sometimes is sufficient. Next, I would like to cover the method of running inference via Python API. In comparison with the previous method of using the command line interface to run inference, this method requires understanding of the neural network library's API, but this method is much more efficient. If using Python to run inference, I personally think this is the better of the two methods. First, make sure to install neural network libraries into your environment as previously described. Then you need to write the following Python code. Let me quickly describe each line of this code. With this first line, we will import the NAPLA-Graph API from the neural network libraries. This line loads the NNP file of the trained model saved using this API. This line reads the loaded NNP file to retrieve the network that will be used to run inference. If training using only the main network, the main runtime network will be used for running inference. If you want to manually specify the network for running inference during the training process, specify the name of that network here. Next couple of lines retrieves the input layer X and output layer Y from the loaded inference network. With image identification neural networks, there is only one input layer and one output layer. With this code, the first value mapped to the 0 position in the index is retrieved for both input and output. To run the training process in Neural Network Console on a neural network with 2 or more input or output layers, specify at least one index to enable processing of the second and subsequent input-output data. The next few lines assign data to the input layer X. The IMRead API is used to assign loaded image files to X. If the image normalization checkbox is selected on the Dataset tab in Neural Network Console, the brightness value is divided by 255 at this time. Now that the data has been assigned, the next line starts the image classification processing. To run inference, the forward command is called for the output layer. Now the inference process will be performed. The next line uses the D accessor to the output layer to retrieve the results of the inference process. As you can see, the neural network determined a very high probability that an input image of a 9 is actually a 9, resulting in the correct classification result. As shown in this tutorial, the neural network libraries can be used together with Python to easily and quickly use trained neural networks. This technology has many practical applications, such as using this together with other business systems to streamline business processes or together with web services to create intelligent features.